Look at this exam response. It looks completely perfect, right? 5 devices named, 5 descriptions given, yet this exact answer just cost a student 60% of their marks on a Cambridge Information Technology paper. Why? Well, because they fell straight into the single most common trap in hardware questions. They described the device instead of applying it. Today, in this explainer, we're going to fix that mistake for good, master output devices, and lock in those top band marks.
So, here's the battleground. You're sitting there looking at a 10-mark question with 5 images. The prompt says, name the output devices and give a suitable application for each. Seems simple enough, right? But the wording here is actually incredibly specific. And let me tell you, Cambridge examiners are totally ruthless when it comes to precision. Naming a broad category, that's going to get you a 0. Stating what the device literally does instead of how it's actually used, yep, that's a 0 too.
Okay, let's dive into this direct comparison to see where it all goes wrong. The flawed answer says, device 4, printer. Application, producing hard copy. This is such a classic trap. Printer is way too generic, and producing hard copy is just a dictionary definition of what a printer does. Now check out the top band answer. Device 4, inkjet printer. Application, produce a one-off, high-quality color photograph. See the difference? It names the exact technology and gives a highly specific real-world context. To write answers like the one on the right, you need a rock-solid grasp of the hardware.
Which brings us to Section 1, Visual Displays Decoded, where we'll master monitor tech.
Now, to give those ultra-specific applications, you first have to actually distinguish between display technologies. The syllabus demands that you know the evolution and the specific use cases of CRT, LCD, and LED displays. So, CRT, or cathode ray tube, that's your old, bulky, heavy technology. Then you've got LCDs, which use tiny liquid crystals backlit by LEDs. And finally, true LED screens, which are made up of a matrix of tiny light-emitting diodes that produce their own light. Basically, you can't just write monitor on an exam anymore. You have to know exactly which one to deploy and, more importantly, why.
And this brilliantly illustrates exactly what examiners want to see. Just look at the contrast here. If you're hit with a question about an old CAD system using a light pen, boom, CRT is your answer, even though it's heavy, gets hot, and flickers. But for practically everything else today, tablets, smartphones, laptops, LCDs and LEDs are the undisputed standard. Why? Because they're lightweight, they use low power, and there's zero flicker. You do need to remember the trade-offs though. LCDs need that backlighting, which can sometimes cause uneven illumination, while true LEDs, they offer amazing contrast, but yeah, they're definitely more expensive.
All right, we really need to talk about touchscreens next because they hold a super unique place in the syllabus. They are both an input and an output device. You aren't just looking at the screen, you're physically interacting with it. And the examiner absolutely loves specific applications here. Please don't just write using a phone. Instead, write ticket collection machines at railway stations or information kiosks at an airport. Why those? Because they allow really fast data entry without needing a keyboard, the glass surface is super easy to wipe clean for public use, and hey, there are no physical buttons to snap off or break.
In a moment, I'll show you the hidden examiner clue that completely changes how you need to write your answers. A clue that literally flips a 4-mark paper into a 10-mark paper. But first, you need the underlying hardware framework that makes that exact clue totally obvious. And that means we have to tackle the most heavily tested and honestly most confused hardware category of all.
So let's jump into Section 2, choosing the right printer, and moving way beyond just the word printer.
Now, this right here is where ordinary revision completely fails. People just memorize the word printer and call it a day. On a Cambridge exam, that is a guaranteed way to tank your score. Laser printers and inkjet printers are entirely different beasts, guys. Laser printers use a rotating drum and dry toner. They are built for the office. We're talking fast, high-volume, high-resolution text. A quick heads up, though, they do produce ozone gas. Inkjet printers, on the other hand, use wet ink cartridges. These are absolutely perfect for low-volume, one-off, incredibly high-quality color photographs, or even printing on unusual materials like a t-shirt. If the exam asks for a device to print 1,000 black and white brochures and you write inkjet, you fail the question. You've got to choose laser for volume and inkjet for photos, no exceptions.
But what about the really specific niches? Because this is where the top band marks actually live. Take the dot matrix printer. It uses an inked ribbon and a print head made of pins. Yes, they are incredibly slow, outdated, and deafeningly loud. Seriously, they sound like an angry robotic woodpecker. But they are absolutely essential for one highly testable application, multi-part continuous stationary.
Think carbon copy wage slips, especially in damp or dusty factory environments where other printers would just jam and die. Then you have 3D printers, which use additive technology to build solid objects layer by layer. The killer application to remember here, bespoke. Unique items, things like custom prosthetic limbs or maybe replacement parts for a vintage car that literally aren't in production anymore.
Moving right along to Section 3, Specialized Output Devices. Get ready, because these are the exam curveballs.
These are the tricky ones that love to show up as image number 4 or 5 on a diagram paper just to throw you off. First, a plotter. It doesn't just print, it actually uses pens to draw highly accurate architectural blueprints and complex engineering drawings on massive sheets of paper. Next, speakers. Sure, they convert electric signals to sound for multimedia, but even more importantly for the mark scheme, they act as crucial accessibility interfaces for people with visual impairments. Finally, actuators. This is the ultimate curveball. Actuators actually control physical devices like motors or water pumps within a control system. So here's the absolutely crucial takeaway. If a computer is controlling a physical actuator, it must, and I mean must, use a DAC, a digital to analog converter interface. Burn that link into your memory.
All right, let's test your retention right now with a real syllabus-style scenario. Pause and predict for a second, which one of the following printers would you use to produce carbon copies, so multi-part forms, of invoices? Think back to what we just covered about specialty printers. Got your answer? Well, if you said the dot matrix printer, you hit the nail right on the head. It's the physical mechanical impact of those pins hitting the paper that makes the carbon copy actually work.
Okay, let's bring it all together in Section 4, Achieving Top Band Marks, where we build the winning framework.
So you know the specific device names now, and you know their contextual uses. But how do we guarantee this translates into top band marks? Now, what's really interesting about this slide is why this seemingly correct answer lost so many marks. This student scored a painful 4 out of 10. For device 3, they wrote monitor with the application showing output on a screen. For device 4, they wrote printer with the application producing hard copy output on paper. To the untrained eye, nothing here is technically false, right? But in the Cambridge ecosystem, it's a total disaster. Let's look at what the examiner actually had to say. Read this quote directly from the source material. The examiner notes, "The answer monitor isn't enough since the image is clearly a touchscreen. The answer printer is not enough and would gain no marks." You see, precision is an absolute requirement here. The examiner is literally looking at the image provided on the paper, which shows a finger touching a screen. If you just write monitor, you are completely ignoring the visual evidence sitting right in front of you. You have to name the exact specific device shown.
And here is the second, honestly, most vital piece of examiner feedback you will ever hear. Quote, "The first 4 answers given are not applications. They are simply describing what type of output is given by the device." Listen, stating that a speaker produces sound is just giving the dictionary definition of a speaker. An application demands context. Writing something like producing spoken word in a multimedia presentation, or providing an audible warning in a nuclear power station safety system. Now those are actual applications that get marks.
So let's synthesize all of this into your winning framework for exam day. Step 1. Name the exact specific device. It's not a printer, it's an inkjet, a plotter, or an actuator. Step 2. Match it to a precise contextual use case. Give the examiner the where and the why, like printing architectural blueprints or manufacturing bespoke vintage car parts. And step 3. Keep it brief. For a 1-mark application question, please do not write a whole paragraph. State the point, provide the evidence, give your explanation, and move straight on.
All right, you now possess the hardware framework and the exact phrasing needed to secure full marks when you're asked to name a device and provide an application. But here's the crazy part. What happens when the exam paper changes just one single word in the prompt, shifting from name to evaluate? Well, the hidden cause of most failed IT papers isn't actually a lack of hardware knowledge, it's a total misunderstanding of these command words.
To guarantee your grade, you absolutely must know how to decode those commands. If you don't, all this hardware knowledge won't save you. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Our next explainer tackles those exact command words that decide your mark band, so it is a mandatory next step. Click the video on your screen right now, and let's go figure out how to beat the examiner at their own game.